Welcome to Part 3 in the iPrep for Intro to Epidemiology series on 2x2 tables. This video will go over incident rates and introduce risk ratios. We will then go over how to calculate a risk ratio using a completed 2x2 table and learn how to interpret the answer. Now that we know how to fill out a 2x2 table, let's learn about some of the calculations that can be done with this information. We will start by reviewing an incidence rate. There are several different incidence rates you will learn in public health, but for our purposes, recall that the incidence is simply the number of new cases divided by the population at risk in a given time period. The population at risk is just everyone who could be susceptible to the outcome at that time. Incident rates are the foundation of risk ratios. The first calculation we will perform using a 2x2 table is the risk ratio. This can also sometimes be referred to as the rate ratio or relative risk, so this is good to keep in mind for exams and homework problems. A risk ratio is the number that allows us to compare the risk of getting a certain outcome between the exposed and unexposed groups. The formula you see here basically takes two incidence rates for the exposed and unexposed and compares them to each other. We're basically asking whether the exposed group is at more risk for the outcome than the unexposed group. Using the 2x2 table that we made in video 2, assessing the association between smoking and heart disease, take a moment to pause the video and see if you can calculate the risk ratio. First, we will start with the incidence rate for the exposed group. So I'm looking at this top number of our fraction here. And this is going to be A, which is 75, divided by our total A plus B. Over here is 100. Here you can see why having these totals handy helps with the math. It makes it a little bit easier. Then we put that all over the incidence rate for the unexposed group, which would be cell C divided by the total of C plus D. Then we can plug that into the calculator. You get 7.5. Now we have our answer, but we also have to interpret it. Is 7.5 significant? Well, think about what our risk ratio would be if both exposure groups had the exact same risk. It would be 1 or very close to 1 because if the exposed group was 1 time as likely to get the outcome, then both incidence rates would be the same, and the difference in risk would not be significant. But with an answer of 7.5, we can definitely call this difference in risk significant. When reporting it, we would say the exposed group has 7.5 times the risk of the outcome than the unexposed group. Or in this case, smokers are 7.5 times as likely to have heart disease as non-smokers. This is made up data, by the way, just for the sake of practice. Let's try another example, but with an exposure that ends up being protective, meaning it actually decreases your risk for the outcome. Take a moment to pause the video and see if you can complete the 2x2 table on your own. Alright, let's read through this together. You are performing a study to determine if getting the flu shot decreases the likelihood of coming down with the flu. 400 people in your study received the shot, of which 30 got the flu. 200 people in your study did not receive the flu shot, of which 25 got the flu. Now, let's start by filling out our table with the exposure and outcome like we did in video 2. Our exposure here is getting the flu shot. Flu shot or no flu shot. Now our outcome of interest are those who ended up with the flu. Flu, no flu. Now we'll fill in what is given to us. We know that 400 people total received the shot. That would go here in our exposure total. Of those 400 people, 30 got the flu. Now we also know 200 people did not receive the flu shot in our study. So that's our total not exposed group. Of those 200, 25 of them got the flu. So now we need to run through here and fill in the missing information using addition and subtraction. So this is 370 because we have 400 minus 30. We have 175 here. We can also fill in our total here by adding these two together. That gives us 600. And then we'll just total these down. And this gives us 55 and 545. Now that we have a complete table to work with, take a minute to pause the video and calculate the risk ratio using the formula we learned. Alright, so we start with our exposed incidence rate at the top here. We have A divided by the total of A plus B all over cell C divided by the total of C plus D. When we plug that into our calculator, we get an answer of 0.6. This time we have a number less than 1, so how do we interpret this result? Well, a result lower than 1 indicates a protective effect, meaning that the exposure was actually beneficial, not harmful. When reporting this, we would say, the exposed group has 0.6 times the risk of the outcome compared to the unexposed group. Or in this case, those who got the flu shot were 0.6 times as likely to have the flu than those who did not get the flu shot. Interpreting risk ratios can sometimes be a confusing area for Intro to Epi students, so here are some tips that may help. Using the following wording in your interpretations will always be safe, whether the exposure is harmful or protective. You say the exposed group has blank times the risk of outcome compared to the unexposed group. It's important to avoid words like more or less because this causes confusion. For example, if our risk ratio of 0.6 was 0.6, like in our last example, it does not mean 0.6 times less likely. It's actually illustrating a 40% decrease. Risk ratio of less than 1 is an inverse relationship. This means the exposure reduces the risk of the outcome. A risk ratio of more than 1 is a direct relationship in which the exposure increases the risk of the outcome. A risk ratio of 1 or very close to 1 would mean there's no significant relationship between the two. So to recap video 3, we reviewed incidence rates, learned how they are part of risk ratios, calculated a risk ratio using completed 2x2 table, and learned how to interpret risk ratios. We also discussed some tips to help prevent confusion when reporting these interpretations. Please continue to video 4 where we would dive into odds ratios next.